Okay, everybody, welcome back. Hope you guys had a nice break. Today we're going to start on the second half of Chapter 8. What we have seen so far is we've learned how to add, subtract, and multiply polynomials. We can multiply a monomial times a polynomial. We can multiply polynomials times polynomials. We can multiply binomials times binomials or binomials times a polynomial. You also learn how to factor out a GCF, and we learned some special case multiplication formulas. The good news, all of that is going to be used for this second half. The bad news, if you were weak on that first half, it's going to hurt you now. Another bad news, if you're not good at multiplication, this is going to be a very tough section for you. I strongly suggest, I'm begging you, learn your times tables. Learn your multiplication tables, guys. You got to know them. From the 1s all the way to the 15s. Okay? The more you know about that and the quicker you are, I promise you, the easier this section will be. Actually, the rest of this chapter. Okay, so today, guys, we're going to start off basic. And we're going to start factoring today. We already learned how to factor out a GCF, a greatest common factor. Today we're going to learn how to factor trinomials in the form of x squared plus bx plus c. Okay, right here. If you notice the coefficient of x squared, it's a 1. It's invisible. So we're going to learn how to factor trinomials where the coefficient of x, in other words, a, is 1. Okay? When the coefficient of x squared, this guy right here, and the coefficient of x squared is 1. When I don't have anything in front of that x squared, I'm going to use the following procedures. Now, please notice that b is greater than 0, and c is also greater than 0. Okay? If b is 0, then you would only have 2 terms. If c is 0, you would only have 2 terms. That would make it a binomial, and therefore this strategy wouldn't work. You need all 3 terms. Bless you, son. Okay? You need all 3 terms. So, let's look at an example because that's the best way to learn this. I want you to factor x squared plus 11x plus 18. I want you to factor x squared plus 11x plus 18. What's the procedure here? Okay, first step is your setup. And your setup, guys, basically you're going to have an x and an x. Now, that is deceiving. It is x and x when it's an x squared. But basically what's happening is you're finding the square root of this first term. So what's the square root of x squared? X. Okay, the square root of x squared is x. You're always finding the square root. And you're putting that square root value here. Now, why is that important? Let's just say for giggles that it was x to the 4th. Then I would have x squared, x squared. If it was x to the 10th, then I'd have x to the 5th, x to the 5th. If I had x to the 20th, then it'd be x to the 10th, x to the 10th. So whatever the leading coefficient's degree is, whatever the leading degree is, okay, just basically divide that by 2. Put one of the values here and the other value there. Yes, sir. If it's odd, then you cannot do this procedure. Okay, you cannot do this procedure then, unless you could have an x cubed here, an x squared here, an x here, and then I can factor out an x from everything, right? The GCF. But if I don't have a GCF, it's a great question, son. You cannot factor it using this procedure. So whatever the leading degree is, divide that by 2 and set up your answer right there like that. Does that make sense so far? Nice and easy. So for 1, my setup is going to be x plus plus. Okay. Step 2. What number times what other number equals the b value This is the B value. But when added together equals the C value. Equals the C value. So this is where your times tables comes into play. This is where your knowledge comes into play. There's going to be people that get this in 3 seconds, and there's going to be people that are going to need an hour, and they still won't get it because if you don't know it, you don't know it. So what times what, guys, equals 18? But when added together, and I messed this up, I messed it up. This is C, duh, and this is B, my bad. My bad. Okay, sorry about that. So what number times what other number equals C, but when added together equals B? 9 times 2, very good. So 9 times 2 equals 18. That's my C value, check. And 9 plus 2 equals 11, which is my B value, check. I'm done. Step 3, plug in the answers into the setup, and you're done. Literally. You have factored the easiest type of trinomial. But still, you have factored a trinomial. Literally, guys, that's it. Put your setup. What times what equals C, but when added together equals B. And then plug in those answers into your setup, and you're done. Does that make sense? Any questions on that so far? Okay. All right. Let's see what else we got now. Okay. Sign patterns. Okay. If you memorize the below patterns, it helps you find your factored answers easier. When the given trinomial, okay, is in the form of x squared plus bx plus c, your setup will always be an x plus times an x plus. Whenever you have a positive b and a positive c, everything in your setup is going to be positive. Always. 100%. Always. This helps you out, and you'll see why now when we're going over some examples. When the given trinomial is in the form of x squared plus bx minus c, when the c is negative here, okay, your setup will always be an x plus times an x minus. Always. I promise. When the trinomial is given in the form of x squared minus bx minus c, so in other words, both the b and the c are negative, your setup will always be x plus times x minus as well. And last but not least, when the given trinomial is in the form of x squared minus bx plus c, so in other words, the b is the only negative, your setup will always be x minus x minus. Always. This isn't something that's going to make or break you. This is just something that is going to help you along the way when you're doing your setup. You don't have to do it with the negatives and the positives. You will see that when you go to step 2 and you ask yourself what times what is the C value, but when added together is the B value. However, if you know these, it's going to make your life a lot easier. Okay, so let's go ahead and put all this stuff to work. Factor each trinomial if possible. Sometimes you have a trinomial that's not possible to factor. If it's not factorable, write prime as the answer, guys. If it's not factorable, write prime as the answer. All right? So, let's get to this. R squared plus 11R plus 24. First, my setup. I have a squared here, right? So it's going to be R and R because half of 2 is 1, and you split that evenly, right, guys? Remember, if this was R to the 8th, that'd be R to the 4th, R to the 4th, right, guys? Okay, so make sure we understand that. Thank you, gentlemen. So now, what times what equals 24, but when added together equals 11? Boom, 8 times 3, that works. 8 plus 3 works. Positive 8, positive 3. We know it works because remember you have a plus and a plus, so we're good. Okay? Example 2, my setup. Now if you pay attention, this is a minus plus. When I have a minus plus, that means they're both negative. So I'm going to go y minus and y minus. Okay? Now, what times what? Remember, what negative times what negative? What times what equals 8, but when added together equals negative 6? Right, negative 4 and negative 2, so negative 2 and negative 4. Done. See how having this setup, you already had the negatives here? You see what I'm saying, guys? Now, I want you to see, though, that let's say I didn't have that setup. Let's say I just set it up like this. Does it really matter? No, because you're still going to put in the negative 4 and the negative 2. So that's why when you're doing the setup, if you see the signs already, God bless you, great, awesome. Go ahead and put them in right now. If you don't see that pattern immediately, don't worry. When you do the second step, you're going to see what has to be negative and what has to be positive. Does that make sense? Yes, sir. To find the setup variables, you only use your leading coefficients, sir. No, what y on the other side? No. When we're factoring, you look at the first term. No, thank you, sir. Okay? The first term only. Okay. Next. All right. I got x squared minus 11x plus 24. So, exactly. It's going to be a negative and a negative for sure. Thank you. Negative 8 and negative 3. Wow, awesome. What times what is 24 positive, but when added together is negative 11? Negative 8 times negative 3 equals 24, and negative 8 plus a negative 3 equals negative 11. Awesome. Awesome. I usually do that part in my head, but since we're teaching it, I want you to see what's going on in my head instead of just writing down numbers. Okay. Next, I've got x squared minus x plus 2. On my setup here, x minus and x minus again, because it's a minus and a plus. So now what? What times what equals 2, but when added together equals negative 1? What? Someone said the answer. No. 1. 1 times 1 is not 2. Okay. Negative 1 times negative 2 is positive 2, but negative 1 plus negative 2 is not negative 1. Come on, guys, think. Positive 1 and negative 2 is not going to give me a positive 2 when I multiply it together. Guys, it's prime. It's not factorable. Okay? It's prime. No two numbers multiplied together give me positive 2, and when added together give me a negative 1. It's impossible. It just won't work. Okay? Thank you. Good questions. Good guesses. Okay, example 5. X squared plus 2x minus 15. I got my setup here of an x and an x, of course. What times, oh wait, I got a plus minus, so minus is one of them and plus one of them. No, when it's plus minus, it's plus minus here. When it's minus plus, then it's minus minus. Okay, what times what equals negative 15, but when added together equals positive 2? Negative 5 and 2 is not negative 15. Wrong. Okay, negative 5 and 3 works, but negative 5 plus 3 does not give me positive 2, so that's wrong. You got positive 5 and negative 3, guys, not prime. 5 times negative 3 is negative 15. 5 plus a negative 3 is a 2. So that works. So I've got my negative 3 and a positive 5. Done. Does that make sense? Yes, sir. What do you mean? Well, the only reason I put 3 and 5 is because I had already assigned my negative there. Let's say that I did not assign a negative there. Let's say that in my setup, I just went X and X, which is fine. Okay, so if I have my setup like this, X and X, and no signs, well, don't I know that one of my answers is a 5 and a negative 3? So plus 5, negative 3. It doesn't matter. I had just put negative 3 first because I put the negative there. Okay? Thank you, son. Okay, next. I've got x squared plus 9x minus 36. My setup, it's going to be an x and an x, and it's going to be a minus and a plus. Okay, so what times what equals negative 36, but when added together equals 9? Who? 3 and negative 12? No, 3 minus 12 is not negative 9. It's 12 and negative 3. Very good. Because 12 times negative 3 is negative 36. 12 minus 3 is 9. So a negative 3, positive 12. Good job, son. Be careful with that. Be careful with the negatives, guys. You've got to test it out. Negative 12 and 3 works for negative 36. But negative 12 plus 3 is not positive 9, gentlemen. Thank you. Okay, let's move on. I got my setup, XX, it's all positive, so plus plus. What times what equals 30, boys, but when added together is 31? 30 and 1, very good. 30 times 1 is 30. 30 plus 1 is 31, yes. Done. Perfect. Great job, son. Okay, next. X squared minus 3x minus 40. I got x, and I got x. And this is going to be a negative and a negative, so when they're both negatives, I got a positive and a negative. Very good, sir. And this is not prime for whoever said that. What times what equals negative 40, but when added together equals negative 3? And no, it is not prime. Yes, sir. Negative 8 and positive 5 makes negative 40. Negative 8 plus 5 is negative 3. Great job, son. Positive 5, negative 8. Boom. Done. Nice job. Well done. Excellent. 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 Okay. Next. X squared minus 2x minus 15. I got an x and an x. And very good, son. It's an x plus and an x minus. What times what is negative 15? But when added together is negative 2. No, negative 2 and 3 does not work. Positive 5 and positive 3 will not work. 5 and negative 3 will not work because 5... Hold on, guys. 5 minus 3 is not negative 2. There you go. Negative 5 and 3, that makes negative 15. Negative 5 plus 3 is negative 2. Bingo. Positive 3, negative 5. Very good. If you guys can see, the negatives are very important. You have to test it out. You don't have to show the work like I'm doing if you don't want to, even though it helps a lot. I suggest it strongly. If you're going to do it in your head, though, you better check everything, though, in your head correctly, please, and be careful with that. Okay, next. X plus 8x, x squared plus 8x minus 20. Okay, yes, sir. An x minus and an x plus. Good job, sir. And what times what equals negative 20? Hold on, my brother, sorry. And what plus what equals 8? Okay, my man. Very well done, son. Positive 10, negative 2 equals negative 20. And 10 plus a negative 2 equals 8. Great job, son. Great job, son. So, yes, I'm going to have a negative 2 and a positive 8. Done. That. Maybe I should learn how to pay attention. 10. Now we're done. Sorry about that mistake. Thank you. Great job, son. Yes. Does that make sense, guys, so far? Okay. Now, factor each trinomial if possible again. If not, factor will write prime as the answer. I'm giving you a little hint, though, here, guys. When factoring, always remember to factor out any GCF if possible. Whenever you're factoring, whether it be a binomial, a trinomial, or a 7-term polynomial, before you start using really heavy factoring methods on it, always, always, always factor out the GCF first, if possible. For example, 11. This setup is not what you learned. You learned the setup when there's nothing in front of the y squared, when there's a 1 there. Tomorrow I'm going to show you what to do when there's a coefficient there. But for right now, is there a common factor here? Yes, sir. Absolutely. So I can divide each of these terms by 5, guys. So I have my 5 that I pulled out because that's my GCF. And then I got y squared minus 4y minus, let's see, 32. Now we can do like normal. So I've got 5 times my setup of a y and a y, and it's a minus and a minus, so it's a plus and a minus. And then what times what equals, remember, now we're dealing with this, not this. We already got rid of that 5. So what times what equals negative 32, but when added together equals negative 4. Negative 8 and positive 4, that's negative 32. Negative 8 plus a positive 4, that's negative 4. So positive 4, negative 8, done. Please, please, please be sure to remember your GCF. Yeah, that's important. So this is nothing new. The only thing we did was factor out the GCF. Remember, whenever you have your GCF, you have to pull that out and then write the leftovers. Yes, sir. What does it have to do with 5 being prime? What does that have to do with anything? Why would it make it prime? A trinomial is prime if it is not factorable, not if it has a prime number in it. Thank you. Yes, sir. No, for lesson 6, I'm going to show you 2 different methods on how to do it. You have what I call the Cuban method, and then you have what's called the column method. So I'm going to teach you both methods, and you guys will choose which way you like. Okay, next. For example 12. Before we start getting to factoring this bad boy, what does anyone notice? Does anyone notice anything about a GCF here? Yes, sir. Yeah, that's exactly right. So I'm going to factor out a negative 3 from everything, giving me an x squared plus 2x minus 8, plus 8. So my setup, I got my negative 3 here, my x, they're both pluses, so plus plus. What times what equals 8, guys? But when added together equals 2. Whoa. Think. 2 and 4 works, but 2 plus 4 is not 2, right? That's exactly right. Good job. And it's not that it's prime, because you did do something to it, right? You factor out a GCF. So the trinomial part is prime, but I just said factor completely, factor this. You did everything you could. So technically this is not prime because you did factor out a 3, correct? But that's my answer right there. Here it is. Done. You cannot go any further. You do not put prime for that because you factored something out. Make sense? Awesome. Thank you, guys. Okay, let's continue. Can I factor GCF from number 13? What can I factor out? A 2, very good. So when I factor out a 2, I got x squared minus 2x minus 24. Now my setup, x, I got a negative and a negative, so that's a plus and a minus. What times what equals negative 20? Negative 24, boys. But when added together equals negative 2. 6 and 4. No, negative 4 and 6 is not going to be negative 2. It's going to be negative 6 and 4. Because negative 6 times 4 is negative 24. Negative 6 plus 4 is negative 2. So here's the 4. Here's the negative 6, sir. And that's my answer, including my GCF that I factored out. Number 14, can I factor something out? What? 7, very good. So I factor out a 7, so I got x squared minus 2x plus 1. I have my setup of an x minus and an x minus this time. So same question. What times what equals positive 1, but when added together equals a negative 2? Go ahead. What you got? Negative 1 and negative 1. That's exactly right. Negative 1 times negative 1 is positive 1. Negative 1 plus a negative 1 is negative 2. Very good, son. But now, guys, when you have an x minus 1 and x minus 1, isn't that the same thing as saying 7 times x minus 1 squared? Very good. So either or, you could have written this one down, or you could have done this one. Either one I would have accepted. Either one I would give you the credit for. Is that fair? Sure. Okay. Next. Okay. Next, what can I factor out of here, if anything? Sir. 4. That's exactly right. I'm going to factor out a 4. So I'm going to get x squared minus x minus 42. Now my setup. X plus and x minus. All right, wow, he already has it. He went x plus 6, x minus 7. He's starting to get this. That's the whole point. I don't ever do this in my, I don't write it down because I've done 1,000 of these already. Write them down, guys, until you start seeing it in your head. So what he did was what times what equals negative 42, but at the same time, when added together, equals a negative 1. So that's where he went, oh, it has to be negative 7 and 6. Negative 7 times 6 is negative 42. Negative 7 plus 6 is negative 1. Done. Last but not least, gentlemen, 2x squared plus 26x minus 60. Can I factor something out of here? Yeah, what can I factor? A 2, very good. So I pull out my GCF of 2, and I got x squared minus 13x minus 30 left over. Now I'm going to go ahead and do my setup. Okay, boys, what times what equals negative 30, but when added together equals negative 13. Okay, guys, whoever said that, yeah, this second part here is prime. This is as far as I can go. Because a negative 10 times a negative 3 is a positive 30, right? I cannot get to negative 13 this way. If you say 10 and negative 3, that's negative 30, but 10 minus 3 is 7. Yes? Oh my goodness, that's not prime. I'm just a ding-dong. Sorry about that, guys. Why don't I pay attention? Hello? I was thinking of only one. Wow, that's a great job, son. Negative 15 and 2. Wow, I'm such a doofus. Sorry about that. Sorry about that, guys. I know I'm human, but still, I just look like a fool. Sorry about that. Great job, son. Great catch. That's not prime. No, that's the answer. Does that make sense, gentlemen? Awesome. That's the lesson, my brothers. Homework is valid. May God bless you. Have a great day.